related to Anchor. Okay, so we can run Anchor build. Okay, so we can see that the code compiled. Everything's good to go. There was a warning generated. So this is just trying to help with formatting. So we can go and make that update with the warning. If we go to our match statement, there were some parentheses here that just aren't needed. So we can get rid of those, clean that up a bit. There we go. Okay, so we can just one more time run Anchor build. It'll be a lot faster now that it's already compiled once. So now that we've built our new program and everything compiled correctly, we can start testing. But first, let's go over everything that happens within this Anchor folder. So when you run Anchor build, it updates the target folder. So you can see here, the target folder is now green, meaning there are new files generated. And we can go into our IDL, and now there's an IDL created for the vesting contract that we just wrote. We have this counter IDL from the previous counter program that was generated with the scaffold, and we can just delete that because we don't need it anymore. And we'll just keep the vesting IDL. Now, there was also a types file generated. We can once again delete the counter file. And what this vesting types, it's a TypeScript file that's compatible with your TypeScript that uses the program IDL. These two are going to be using for both our testing and our front-end application because both of those are going to be written in TypeScript. Now, all of that's done. So let's start with our tests. There is a counter test that's already generated. We're just going to delete that because we no longer have the counter program and we're not writing normal TypeScript tests. We're going to be using bank run here. So let's get everything set up for our bank run tests. So what this does is it creates a Banks client and a Banks server and runs our tests against it. Now, we're going to have to specify the path of our program to be able to deploy the program to the Banks client and run the test correctly. So let's make a fixtures folder inside our test folder. And what that'll do is we'll just import our vesting.so file. So if we go back to target and we go to deploy, you can see our .so is generated. So we're just going to copy that and paste it into the fixtures folder. And this just allows the bank run test to be able to easily access our .so file of the smart contract that we just wrote. And just to clean up a little, you can see the counter key pair, anything counter related. If you see it, just delete it. Okay. Now inside our test folder, we can create a new file, and that's going to be our bank run test. So we'll do bankrun.spec.ts. Okay. Now there's a few packages that we're going to want to install to be able to use bank run. So in our Anchor folder, we're going to npm install. And we want, let's see, what do we already have? We'll go to our package.json. And we have Anchor, we have web3.js. So now we also want to add in the SPL token. So we'll do @solana.spl token. Okay, so you can see there's some dependency issues. So what we're going to want to do is define a specific version. So we're going to do @Solana SPL token, and we'll do .4.8, and we're going to update our web3.js to 1.94.0. Okay, great. Now we're going to install Anchor bank run. Okay. And that'll be version 4.0. And now we're going to install Solana bank run as well. Okay. And that'll be version 2.0. We're going to update the version here. So this is just making sure we have compatible versions for all our dependencies. And then because we're going to be using the SPL token when we're testing, we want to also use the SPL token from Bankrum. So we'll npm I SPL token Bankrum. Okay, and this one, we're also going to update the version to 2.5 instead of 2.6. So let's see, we have our Coral anchor, we have Solana SPL token, version 4.8, we have Web3.js version 1.94, we have Anchor Bankrum, Solana Bankrum, and SPL token Bankrum. Okay, so those are all the dependencies we need for our Bankrum tests. And let's just make sure everything's properly installed. Okay, great. Now we can go back to our Bankrum file and start writing our tests. So first thing, we're going to just set up our test. So we'll do describe, and then we'll name the test vesting smart contract test. Before we start actually running the test, we first want to start with our environment setup. So in our environment, we want to make sure we have an SPL token mint that we're going to be using with the proper authorities. We also want to make sure we have the right programs deployed to be able to test our vesting contract properly. So let's set up our environment first. So we're going to do that by using before all. And what this is going to do is run these specific functions before every single test is being ran. So this is going to be an async function. Okay. Now within the Bankrum test setup, you have a wallet with a payer that is already funded and ready to be able to work. But in our smart contract, we have two different scenarios that are being tested. We have the employer perspective as well as the employee perspective. So we'll keep the default native wallet within the test to be for the employer. But now we have to set something up for the employee. So let's name this beneficiary. And we're just going to generate a new key pair. So we'll do new anchor dot web3 dot key pair. Okay. So we need to first define the type. So outside of our before all, we're just going to let beneficiary be of a type pub key. Okay. And this is TypeScript, so the type is actually public key, not pub key. We're not in Rust anymore. Public key. Okay. Now let's fix our imports. So we're going to make sure we import public key from Web3.js. We also want to import Anchor. So we'll define our first import here as Anchor, and we're going to fix Copilot suggestion, and this should be from Coral XYZ Anchor. Okay, and now we have a typo in key pair, so let's fix that. There we go. And this is actually a key pair, not a public key. So there you go. Now, one thing to note, the difference between a key pair and a public key, the key pair has both a private and public key attached, so you're able to sign with it. And because we need the beneficiary to be able to assign instructions, it needs to be of a type key pair to be able to sign those instructions. Okay, and we're just updating our imports. We'll just keep the public key import there because we will be using that in the future. So we've defined the beneficiary. So next we're going to define our context for Bankrum. So we can do that by await start anchor. Now we'll define what the context is. And the context is your program test context. So program test context. And we'll import that. So the quick import isn't showing up, so we'll manually write that. This is going to be an import from Bankrum. So we'll do import program test context from, and this is going to come from Solana Bankrum. Okay, so we'll be defining our context. We're going to do that with start anchor, and what start anchor does is it starts a bank run in an anchor workspace with all of the workspace programs deployed, and it spins up a bank server and a bank client, deploys the programs and all the accounts that are added. So let's import start anchor, and that's going to come from Solana Bank Run. And let's update our program test context to import correctly. Okay, there we go. Now we're going to update all of the parameters that need to be passed through for start anchor. So start anchor first has the path, which is the path to the root of the anchor project. And because we created this fixtures file with the vesting.so pasted into it, we're able to just make the path an empty string. And now the next parameter is going to be the extra programs. So the program that we need to deploy to bank run is going to be vesting. So we're going to set the name as vesting. And one thing to note when you're naming these programs, it needs to be whatever the name is of your .so file. So you have to make sure that those two values match or it's not going to pull the right program. Okay, so we have the name, and we also need the program ID. So program ID, and this is going to be of a public key type. Now, when we created our librs, you have this declare ID with a public key. This is your program ID. When you run anchor build, it creates an IDL, and within the IDL, you have an address. These two values should be the same. You can see that they are. And this is the program ID of the smart contract that we just wrote. So we can go back here and just pull that from the IDL. So we want to properly import the IDL. So we'll import IDL from, and it's going to be our target IDL vesting.json. That's the file path to get back to this file here. Now, in our program ID, we can just call that address. So we can do IDL dot address. Okay, and now we have a little typo. This should be on the other side. Okay, we passed through our parameters for the added programs. Now we need to pass through what our added accounts are. Now, we talked about earlier how we need to add a beneficiary account. With Bankrun, you already have a signing key pair that has both the public and private key with funded LAMP ports, and we're going to be using that for our employee. But now we have another perspective that needs to be able to sign instructions, and that's our beneficiary. So we generated the key pair for the beneficiary, but now we need to load that key pair in and make sure that it's funded with LAMP ports, so there are LAMP ports to be able to pay the gas fees when executing an instruction. So we can define that here. we'll first specify the address, and that will just be the public key of the beneficiary. And now we'll add in the info for this account. So this is just your typical info data structure. It's going to have the LAN ports, and we'll just fund it with a bunch of LAN ports. And then it's going to have the data, and then it'll have the owner, and in our case it's just going to be the system program. So we can actually import the system program ID from Anchor. And lastly, the executable, which we're going to set to false. And now we're getting an error here, and that's because we have a typo in ID, so it's just camel case program ID. Okay, so that's everything we need for our context. And just to recap, we have our start anchor that has the path to the root of the anchor program. We also have the programs, which is an array of the objects indicating which extra programs need to be deployed to the test environment. And we have accounts, which is just an array of accounts indicating the data that needs to be written to a certain address in this testing environment. So now we set up the context. Now we need the provider. So after context, we're going to define the provider. And this will be a new bank run provider. And the parameter is just the context that we defined in the previous step. Okay, now we need to make sure that first provider's type is defined. So provider is a bank run provider type. And then we just need to import bank run provider. And this is coming from Anchor bank run. So we'll do import bank run provider. From Anchor bank run. Okay, now that we have the provider, we need to set the provider. So we're going to do anchor dot set provider, and that will be the provider that we just defined. We have the provider, we set it. Now we need to define the program. So we have the program, and that's just a new program. And we want to make sure that it is matching the vesting IDL. So we'll add IDL as vesting, and we can import that vesting type from our TypeScript file that was generated. And the other parameter is the provider. Okay, so first let's define the program type. So program is program vesting. We want to import program from Anchor. Now we want to make sure we already did an import of the IDL, but we also want the TypeScript compatible version. So we're going to import vesting from the target types vesting. And this is our TypeScript file. There's two things that we're going to be using a lot throughout our test. So we're just going to simplify that by creating a variable for that. So one is the banks client. So the banks client, one is the banks client, and the banks client comes from the context. So we can name banks client is the context.banks client. And now we'll define the type above. And that is a banks client type. Okay. And the next thing we need is the employer. So we talked about how the provider comes with a wallet that is already funded and has the full key pair of both the public and private key. So we can just name that employer. So we don't mix up our two signing keys that we have. So we have provider.wallet and then dot payer. Okay. And then we'll define what the employer is up here. And that will be a key pair because it is a signing key, just like the beneficiary is. Okay, so far we've set up our environment with the needed accounts and programs. But we also need to have an SPL token mint that we're going to use as the token that we're going to be passing back and forth between our treasury accounts and employee accounts. So let's actually create a mint. And we need to create that so we have the mint authority to be able to mint tokens to the correct accounts. So we'll set mint, and we're going to await, and we'll create mint. Okay, and this is an import from SPL token bankground. So we'll add that import, create mint. From, this will be SPL token background. There you go. Okay. So now the arguments that are passed through for create mint, we have the Banks client, we have the payer, we have the mint authority, the freeze authority, decimals, key pair, and program ID. So let's define all of those. And first, before we do that, let's actually define the mint type. So we'll go back up here and do let mint, and the mint is going to be a public key. So now we have the Banks client. Okay. And then up next is the payer. And in our case, that will be the employer that we defined earlier. And then we want the mint authority. So that is going to be the public key of the employer. For our testing purposes, we don't need to freeze any tokens. So we're just going to leave that as null for the freeze authority. And then for decimals, we'll just put 2. And I have a typo in Banks client, so let's fix that. There we go. I have a typo everywhere in Banks client, so we'll fix all of them. Okay. Now, there's an error, there's a type error with the Banks client, and you can see here that it is between the Solana bankground and the SPL token bankground. So this is actually within the dependencies themselves. So what we're going to do is just do a TS ignore because it does work between the two. So we'll add in at TS ignore. Okay, now there's just a few more things to do to finish setting up our test environment, and then we can go to writing the actual instructions to test the smart contract. So first is setting up the provider for the beneficiary key pair, and we're going to be using a different program when we're actually executing the instruction for the instruction that the beneficiary needs to sign. So we'll just get that set up now. So we'll do beneficiary provider. So that is a new bank run provider. And we want to use the same context that we defined earlier, so we can just do context. Okay. And then we're going to do the wallet. So beneficiary provider dot wallet equals, and this will be a new node wallet of the beneficiary. Okay. Now we need to define what the beneficiary provider type is. So we'll go back up to the top. Let beneficiary provider, and that will be a bank run provider. And now we need to import node wallet. And this is coming from Anchor. Okay, and then we can just define this second program with the new beneficiary provider. So program 2 is equal to new program of type vesting. And then we'll need the IDO as vesting. And it's setting the provider as the beneficiary provider. Okay. And then we'll once again define the type for the new program. So let program 2 equal the program vesting type. And lastly, we just need to derive the PDAs. So we have 3 PDAs throughout our smart contract, and we'll just derive all of those now. So we'll do the vesting account key. And now you're able to find the address from the PDA by just using the find program address sync. And what this does is it generates the public key for a specific PDA. So public key dot, and we'll use find program address sync. And then we need to define our PDA. So for the vesting address, we used just the company name to create the PDA. So we can do buffer.from company name. And then we just need the program ID. So we'll do program.program ID. Now, 2 things. One is defining the type of the vesting account key. So we'll go back up to the top. Let vesting account key is a public key. And then the next thing is the company name. So since the company name is a user input value from the UI, we're just going to explicitly define the company name for testing purposes to make things easy. So we'll make a constant at the top. Company name is just, we'll make a company name for now. Okay, cool. So that's our vesting account key. Now we need a treasury token account key. So treasury token account. And we're going to do the same exact thing. So public key dot find program address sync. And this is where we define the seeds for a PDA. So we'll do buffer dot from. And for our treasury token account, we did vesting treasury as the first part of the seeds. So vesting treasury. And then the second part was the company name. So buffer from company name. And then lastly, we just need our program ID. Okay, we forgot an equal sign, so we'll add that. And we need to define the treasury token account type. So let treasury token account be a public key type. Okay. And the last PDA we need to derive is the employee account. So let's define that. So same exact method. We have our employee account. And that is a public key dot find program address sync. And then the seeds for our employee account was a little bit longer than the rest. So we have buffer from, and it was employee vesting. Okay, and then we had the public key of the beneficiary. And then we had the vesting account key. So we had a typo in public key. So just for a reference, the public key class has a capital K in TypeScript. Okay. And then lastly, we just need to define the program ID. Now let's just fix some formatting a bit. So this is a bit easier to read. Okay, there we go. And now we'll once again define the type. So this will be let employee account be a public key type. Okay, so that's everything for the PDAs that we need to derive. And it looks like we have everything set up for our testing environment and we can start actually testing. But let's just recap everything that we wrote. So before all, sets up the environment, and this is going to be ran before every single test that's ran. And here we're setting the beneficiary key pair. We're running start anchor, which is setting your bank run in the anchor workspace, and it's creating the bank's client and the bank server. It is specifying the path to your .so of the smart contract that we're testing. It's specifying the programs that we need to deploy, which in our case, it's just the vesting contracts. And then it's also specifying the accounts that need to be funded and have specific data written to it. And for our case, it's just funding the beneficiary account. We're setting our provider, running anchor set provider, naming our program, setting the bank's client. We're creating a mint address with the employer being the authority. We're updating the provider for the beneficiary. And then we're getting all of our program addresses for each PDA that we need to derive with the seeds that we're specifying. Okay, great. So now we can start writing our test. So we'll go outside of the before all and write our first test. So we're going to create a vesting account. Okay, and this is going to be an async function as well. And now we can write our first transaction. So we'll do const tx and await. And now we can just call the namespace from the program. So we'll do program.methods. And now we can call the create vesting account instruction. So create vesting account. And all we're passing through as a parameter here is the company name. So we'll write company name, which is a constant that we defined earlier. And now we need to define all of the accounts that need to be passed through to run this instruction. So when we're creating a vesting account, we need the signer, we need the mint, and we need the token program. So we're going to set accounts. And signer is going to be the employer, but it's going to be the public key. And then the mint is just the mint that we already defined. And then the token program and this is just the token program ID. There we go. So with the new version of Anchor, any account that is a PDA that needs to be derived, it automatically does that for you. So you're just passing through the additional accounts here. Okay, so now we need to send the transaction. So we'll do .rpc. And then the commitment is confirmed. Now we're just going to console log our transaction. So we'll do console.log and then creates vesting accounts, and it will be our transaction. So another thing we can log actually is the vesting account data, just to make sure that the vesting account was created correctly. So let's do const, we'll do vesting account data. Await program dot account dot vesting account, and we can fetch our vesting account key. Okay, and then we'll just console log that. Now we can run our first test, make sure it works. So in our Anchor folder, all you need to do is run Anchor tests, and it will run all of the bank run tests. So you can see it's recompiling the Anchor program. And now it's running the test suite, and you can see our test passed. So let's go back to our logs. Within Anchor bank run, so here's our test. It's running the bank run spec TypeScript file. It's running Solana program test. Here are your runtime messages. And then here's our console log. So the vesting account data, we have the owner is the public key. We have the mint address. We have the treasury token account, the company name. We have the bump for the treasury and the bump for the vesting account. And then we also have the transaction of our create vesting account. And you can see in our test suite, we have one test passed, and the test was named should create a vesting account. Okay, so now we can go on to the next test. So in our first test, we created the vesting account. Now the next instruction that we want to test is creating an employee account. So let's write that test out. We'll do it should create a... Actually, before we create the vesting account, we need to fund the token account. So let's think back at what we just did. So we created a vesting account. And when the vesting account was created, not only was the account that's holding the state for the vesting account created, but a treasury token account was created as well. Because when we wrote our context data structure for creating the vesting account, we had two initializations. We had the initialization for the vesting accounts and the initialization for the token account for the treasury. So this token account needs to be funded to be able to pass tokens from the token account over to the employee's token account later on in our tests. So since the SPL token, mint, was created with the employer as the mint authority, we're going to be able to mint tokens to the token account that was just created to fund it. So let's add that as the next step as our test. Should fund the treasury token account. So let's define the amount that we want to fund. So this is going to be in Lamport. So we'll do 10,000 times 10 times 10 to the 9th. Okay. Now we can just execute the mint transaction. So we'll do mint tx await, and we're going to run mint 2. Okay. So we want to make sure that we import this, and we're going to update the import from the SPL token bank run. Okay. Now this has a few arguments. It's very similar to create mint. So first we want to pass through the banks client. This is going to generate the same type error from create mint, so we can just copy over our little comment here. And now we have employer as the next argument, mint, and then the destination is going to be the treasury token account. And we can just pull in the key that we derived earlier. And then the employer is going to be the signer. And then the amount is going to be the amount that we just specified above. Great, so now we can just console log that transaction. And let's run Anchor tests to make sure that went through. Okay, so you can see our whole test suite passed, which included 2 tests, and those both passed. So now our treasury token account is funded. So we can move on to the next step. And this is going to be creating an employee vesting account. So now we can just define our transaction, and this is going to be the second instruction of our program. So we'll just name it tx2, and we're going to await. We'll call program.methods dot, and we'll do create employee account. Now this has several parameters to be passed through. So let's see. It has the start time, the end time, the total amount, and the cliff time. And because these are both I64 and U64, those convert to big numbers in TypeScript. So we're going to create a new big number, and we'll do, just for simplicity, we'll set the start time to 0 and the end time to 100. We'll set the cliff time also to 0 and the total amount to 100. So total amount is next, and then the cliff time to 0. This just helps us with testing because it sets the, so we don't have to wait for the cliff to pass. Okay, so now we'll just import bn from Anchor. Okay. So next is passing through the accounts. So accounts, and we'll need the beneficiary and the vesting account. Okay. And lastly, we'll send the transaction. So RPC, commitment confirmed. And we're also going to skip pre-flight to true. So there we go. So we'll console log this transaction, make sure it went through. Okay, and then we'll just confirm the employee account. So we'll just console log the employee account address. And this is going to have to be 2 base 58. Okay. Now we'll run anchor test one more time. Okay, so you can see the test suite passed, all 3 tests have passed, and it names each test. We can just go back to our console log to just check everything. So we have our first instruction, and it created the vesting account, and there's our transaction signature. We have creating an employee account, and here's the transaction signature. And then this console logs the employee account public key. And we also have the minting tokens to the treasury token account. Now, the last thing we need to check is claiming tokens. So we'll make one more test. So should claim tokens. So now, because we need time to pass here to be able to claim the tokens, we're going to use a clock. So we're going to const current clock is equal to await, and from the Banks client, we can just get the clock. So Banks client dot get clock. Okay. And now we can set the clock in our context. So const dot set clock. And this will be a new clock with, and we're going to use the current clock slot. And then current clock epoch start time. And I spelled current clock wrong. Let's fix that. Okay. And then let's make sure we import clock. So this is an import from Solana Bankrum. Okay. And now we can see all of the arguments needed. So clock, start time, we need epoch next. So we'll do current clock.epoch. And then next is the leader schedule. So current clock dot leader schedule epoch. And then last is the Unix timestamp. So we'll just set this to 1000 in. Okay, now our clock's set. Now this is gonna take a little bit longer in our bank run test. So we're just going to set a timeout. So we'll do await new promise. Resolve. Set timeout. Okay. Now lastly, we're going to run our third instruction of the smart contract. And here, we're actually going to use the second program because the signer for this instruction is going to be the beneficiary and not the employer. So methods, and we'll call claim tokens. Okay, so what we're passing through here is just the company name. Now we need to add the accounts. And for this, it'll just be the token program. And then we need the RPC commitment confirmed. Okay, and now we'll just console log our transaction. And this is our last test to run. So we'll run anchor test and see if the employee was able to claim their tokens. Okay, so you can see all 4 tests have passed. The full test suite has passed, and we can just look back at our console logs from the beginning of our bank run test. So we have the vesting account. When we're creating the vesting account, your transaction was logged. We have the minting to the treasury token account. We're creating an employee account. Here's the employee account public key. And then here is our claim tokens transaction. Okay. So now that our tests have worked and we have our program built, we're going to be able to deploy our program. So in this whole bootcamp, we're going to be using our local testing environment. So let's get a local test validator running, and then we can deploy to it. So we're going to go back to our terminal, and let's just do Solana test validator. So running the Solana test validator just initializes a new test ledger and then is running a local validator on your computer. Now that this is loading, you can see that it is loading to my local host, and we're able to now use it. So once you build a program, you're able to deploy. So we can just run anchor deploy, and we're going to specify the cluster that you want to deploy to. So we'll do provider.cluster. And this will be our localhost. Sorry, with Anchor, it's localnet. With Solana, it's localhost. Okay, there we go. So you can see it's deploying vesting. And you can see this is our program ID. Now, one thing to check is you want to make sure all of the program IDs are synced. So we're going to run Anchor keys sync and make sure we're using the correct program ID throughout the entire workspace. Okay, so you can see all program ID declarations are synced. There was an incorrect public key in our Anchor TOML, so this was updated by running Anchor key sync. So just because there was an incorrect program ID, we're just going to go back and rerun Anchor deploy, make sure everything's correct throughout the workspace. Okay, great. We're going to start working on our front end. So we can take this program ID and connect it to our front end. So in the Create Solana DApp scaffold, there is one part that doesn't automatically update the program ID, and you have to manually update it. So we're going to go there and make sure that it's using the correct program ID. So that's here in our exports, and we actually need to fully update our exports because it's still working for our counter. So we're going to update our counter exports for our vesting program. So let's rename this to vesting exports. And what this is doing is it's exporting information needed to be able to pull into our web folder when we're creating our web app. Okay, now everything that's counter we want to update. So this is actually our vesting IDL. And this is coming from idl.vesting.json. Okay. And we're going to import the vesting type from our target types vesting file. Okay. So now we can export our vesting and vesting IDL. Now we'll update the program ID for vesting. So vesting program ID. And this will be the vesting IDL. And now this public key should be the same as the program ID here. So we're just going to paste this in. Okay. And this will be the vesting program ID. Now we're going to go back into our files and just check for counter. Okay. Great, so you can see everything left with counter is in our React app. So we can worry about that as we're building out the front end. Now we can close out our Anchor file and open our web. Okay, so if you look on our web folder, we have the app folder, we have components, and we have public. We're gonna start out in components. So you can see the components are separated between account, cluster, counter, dashboard, Solana, UI. What we're updating is the counter, because the counter is the area that's connected to the Anchor program. So let's rename this to vesting. Let's also rename this to vesting. Okay, just for consistency. Now you can see the vesting component is split into 3 sections. We have data access, we have feature, and we have UI. Let's first work with data access, because that's where we're going to be accessing all of the information needed to display on the UI. So we're going to import our get vesting program this time, and get vesting program ID. Okay. We'll just update everything from counter to vesting. Okay, so when you're using the vesting program, it's going to be making a query. And what we're going to want to set up is a query for the vesting accounts. So we're updating that. Now it's getting the program accounts based on the program ID. Now here's the initialization. We want to update this to initialize our new vesting accounts. So let's remove the initialization function. And this is just coming from the counter program. You had to initialize the counter program. So let's make this create vesting. Actually, let's keep this just to follow the same format, and we're just going to rename it. So we'll do create vesting account. Now this is program.methods, and it's going to be your create vesting account. This is going to pass through a company name and a mint address. So we have our company name, now this is a user input, and we're pulling this from the front end. And because we're doing that, we're going to have to tell this mutation that we're doing that. So we're going to update the mutation to we have a string, we have an error, and we also need to specify our arguments. So create vesting args, and let's write an interface to define what that is. So we'll do interface create vesting args, and we'll need the company name. And we need this because this is a user input parameter, and we're using this as an argument for the create vesting instruction. And this is its string type. Now, another thing that we're going to have to pass through is the public key of the mint. And that's because we don't derive the mint account anywhere. So we need to pass through what the mint account is. And that is an account that's being used within the context data structure when you are actually creating the vesting account. But since it's being an input on the front end, we're going to make the type a string. And later when you're using the value, we're going to have to generate a public key from it. So we're passing through the arguments that we need. Our mutation key is going to be our vesting account creates. We're using the cluster. Okay, so here is where we want to pass through the company name and the mint. This is because these are the two arguments that we're grabbing from the front end and then passing through. So we just need to specify that. Okay. Now we can run program methods, and we're using create vesting account, and the only parameter that's being passed through there is the company name. Okay. And then the accounts that we need is going to be our mint account and the token program. So we'll go back to accounts, and we'll do the mint. And that is a new public key of the mint. And we're creating a new public key type because the mint is being passed through as a string type. And now we also need the token program. Okay. And then we'll just import the token program ID. And then we don't need a signer because we're going to actually be using the wallet that is connected to the front end of the application. So we'll just use the RPC, and then on success, it'll sign. And on error, it will give failed to create vesting account. Okay, great. So now we'll just update the return, and that is going to be create vesting account. Okay, so that's all the data we need for using the vesting program. Now we want to be able to use a vesting program account. So what this is going to be is once an employer has come to the front end and they have created a vesting program, now they can go in and update that vesting program by adding in employee accounts. So we'll go to use vesting program account. And this is passing through the account. Okay. Now we'll do use